Okay, welcome back. Today we're going to talk about balancing chemical equations. We've got a lot of examples that we're going to run through in this video, but make sure you have your guided notes open and be filling out some of these practice problems as we go through it. Okay, so we haven't balanced chemical equations for a while, so I've got some example problems that I think will help. So let's go through the first one here. Maybe. Okay, here it is. Okay, number one. I don't think you guys have this in your notes, do you? No. Okay, so let's, here's what I always do. I find the arrow. This arrow separates your reactants on this side from your product, and draw a line straight down. Okay, and then you list the elements that are present on each side. I just list them in order. We've got hydrogen and we've got oxygen. Now if you list it in that order on the left side, it's going to be in the same order on the right side. Okay, help me out. How many hydrogens do we have? Two. How many oxygens on the left? How many hydrogens on the right? How many oxygens? One. Okay, then what I do is I just go down the list from the top to the bottom. Hydrogen. Are we balanced? Yep. What about oxygen? No. How could I balance the oxygens here? Yeah, I need to get this to a 2. How do I get 2 oxygens over here? The only number you can change is this number out front, which is called the coefficient. So instead of 1 water molecule, I need 2. Okay, that will give me how? But does that change my hydrogens though? Yeah, it gives me how many? 4. So we just kind of update that. And how many oxygens? I now have 2. Okay, that was great for oxygen, but it then threw off my hydrogens. How would I fix it? Put a 2 in front of this hydrogen. Yeah, so now we have how many? 4. Are we balanced now? Yeah. So according to this, we're all balanced. Now let's look at the coefficients. We have a 2, a 1, and a 2. Can I reduce 2, 1, 2? No, because this 1 right here is already as low as it can go. So there's our answer for that one. Yeah, good job. All right, let's do this one. Okay. Again, what's my first step, guys? You tell me.
The arrow.
Yeah, find the arrow and do what? Yeah, draw a line down. That kind of separates the reactants from products. That's very important to do. Now what do? Write down the elements. Thank you, Ruben. Speak loud. What elements do we have? Hg. What is Hg? Mercury. And we have oxygen, right? Again, put them in the same order on the other side because it just lines up better. Your mercuries line up and then your oxygens will line up and you can see it better. Okay, help me out. Let's go fast. How many mercuries on the left? 1. How many oxygens?
1.
How many mercuries on the right?
1.
How many oxygens? 2. Okay, mercury. Is it balanced? As is? Yeah. What about oxygen? No. What do I need to do? I need 2 out here because that would give me 2 oxygens, but does it do something to my mercury as well? Now I have 2 mercuries. Okay, let's fix the mercury. Add a 2 on this side, and that will give me 2 mercuries. Are we balanced? Okay, now it's a good idea to ask yourself, can you reduce it 2, 2, 1? Nope, so there's your answer. Good job. Let's try another one. Find the arrow, do what? Draw the line down. Okay, what elements do I have? Nitrogen. Hydrogen. Again, keep them on the same order on both sides. How many nitrogens, guys? 2. How many hydrogens?
2.
How many nitrogens?
1.
How many hydrogens?
3.
Okay. I just worked from the top down. How do I fix the nitrogens? Yeah, I need a 2 right here. The only way to get that is put a 2 right here. Gives me 2, but how many hydrogens do I have now?
6.
So always update if it changes all of them, so you got to update it to 6. Okay, how do I get 6 hydrogens on the left side?
3.
I have to put a 3 as a coefficient in front of the hydrogen. That gives me 6. Okay, can I reduce a 1, 3, 2?
No.
Nope, so we're done. Okay, we're working our way into more complicated ones here. Again, though, it's going to be the same process. Find the arrow, draw the line down. What elements do I have? Help me out. Sodium, hydrogen, and oxygen. Okay. How many sodiums on the left? 1. How many hydrogens? 2. How many oxygens? How many sodiums? How many hydrogens? Yeah, you have to be careful here because it splits, huh? There's 1 here and there's 2 here, so that's 3. How many oxygens?
1.
Just 1. Okay, let's work our way down. Sodium is already balanced. Hydrogen, how do we fix it? When you're looking at this problem, with hydrogens on the left, whatever number you put here, can you ever get to an odd number of hydrogens? You can't. It's always going to be even. So let's keep that in mind. Let's try to get to an even number on the right side. How could I get to an even number on the right side? Yeah, in front of this sodium hydroxide, let's put a 2 right here. Let's do hydrogen right now. That gives me 2 hydrogens here and 2 there for a total of what? 4. But that did switch my sodiums to what? 2. And my oxygen to what? To 2. Okay. So now let's go back to sodium and fix it. How do I fix sodium, guys? 2 in front of it. That gets me to 2. Now I got to get hydrogen to 4. Yeah, I need a 2 right there. That gives me 4 hydrogens. And my oxygens is 2. So everything worked out. Can I reduce a 2, 2, 2, and 1? Nope, so that's it. Okay, I've got a few more. Let's go through them. Number 5. Find the arrow, draw the line down. List the elements, Fe, which is iron, and oxygen. Let's list them in the same order. How many irons on the left side?
1.
1. How many oxygens?
2.
How many irons on the right?
2.
How many oxygens?
3.
Okay. Let's just start at the top. How do I fix the iron?
Put a 2 for me.
Put a 2 here. That gives me 2 irons. Okay, now my oxygens. Okay, when you get to this point, you have 2 and 3. You should ask yourself, what's the lowest number that both 2 and 3 can go into? 6. We need to try to get to 6. So how would I get to 6 on the left side?
Put a 3.
3 here. That gets me to 6 pretty easily. All right, how do I get to 6 on the right side? Put a 2 right here. That gets me to 6 oxygen. But does that change my irons? Yes, it does. To what? 4. Okay, now let's try and update this one. How do I get to 4 on this side? Yeah, instead of a 2, I need a 4 right here. And that will give me to 4. Okay. Can I reduce a 4, 3, 2? Nope. So that's your answer. Okay, 6. Let's draw the line down from the arrow. It looks like I have aluminums, irons, and oxygens. Again, listed in the same order so that we can look straight across and it's all lined up. Okay, how many aluminums? Let's go fast.
1.
1 here, irons. 1 oxygen.
1.
Aluminum.
2.
Iron.
1.
Oxygens. 3. Okay. I just worked from the top down. Aluminum, how do we fix it?
Put a 2.
Put a 2 right here. Okay, that gets me to 2 aluminums. That balances it. Iron's already balanced. 1, 1. Oxygen. 1 and 3. How can I fix that? Yeah, I need a 3 right here. That will get me to 3 with the oxygen. But does that switch my iron?
Yeah.
It does to what?
3.
To 3. Okay. Now everything's good except for iron. How do I fix it? Yeah, I need a 3 as a coefficient right there. And that gets me to 3. Can I reduce a 2, 3, 1, 3? No. So that's as low as it can go. That's your answer. Okay, I've got a couple more. Number 7. Let's find the arrow, draw the line down.
Potassium.
Potassium and bromine. Okay. How many potassiums on the left side? One. How many bromines? Two. How many potassiums on the right? And how many bromines? One. Okay. Potassium is already balanced. Bromine, how do I fix it? I need a 2 here. That gets me to 2 bromines. Does that change my potassium though? Yes, to 2. How do I fix it? I need a 2 over here. That was a pretty easy one, right?
Yeah.
Can I reduce it at 2, 1, 2? Nope. So that's it. Okay, last one. This is a combustion of a hydrocarbon. These can be kind of complicated sometimes. So let's go through an example like this. Draw the line down. It looks like we have carbons, hydrogens, and oxygens. Carbon, hydrogens, and oxygens. All right. How many carbons on the left?
7.
7. How many hydrogens? 16. And how many oxygens? 2. How many carbons? 1. How many hydrogens? 2. And how many oxygens? 3. Yeah, be careful. They're split. So there's 2 here and there's 1 over there. Okay, I just worked from the top down. Let's balance carbons. What would you do? Yeah, I need a 7. We need 7 CO2s. That gets my carbons to 7, but what does that switch? Oxygen to what? 14 plus 1 is what? 15 oxygens. Okay, so 15 here. Okay, so my carbon's good. Let's go to hydrogen. How do I balance the hydrogens here? Yeah, I've got to get to 16 on the right side, so that's got to be a what right here? An 8. That gets me to 16. And how many oxygen do I have now? So there's 8 there plus 14. What's 8 and 14? 22. 22, excuse me. Okay, 22 oxygens. Okay, let's see if we can get that on the left side. Yeah, it worked out great, didn't it? So 11 right here gives me to 22. And so carbons are balanced, my hydrogens are balanced, and my oxygens are balanced. Can I reduce at 1, 11, 7, and 8? No, that's it. So hopefully that helps you remember how to balance chemical equations. I think they're pretty easy to do if we keep that method. Okay, when we balance equations, especially word equations, we need to know the 7 diatomic molecules. There's 7 of them. What does di mean, guys?
2.
Di means 2. What does atomic mean? It means atoms. So these are 2 atom molecules. There's 7 of them that we need to know. And there's an easy to remember mnemonic that will help you remember all 7 of these. Remember this from last year? Ostriches never fly high in brown clouds. If you look at these that I'm underlining, these are the symbols for all of the 7 diatomic molecules. What do you think O is for? Oxygen. What is N? Nitrogen. What is F? Fluorine. What is H? Hydrogen. What's I? Iodine. What's Br? Bromine. And Cl? Chlorine. Yeah, so number 1 is oxygen, then nitrogen, fluorine, hydrogen, iodine, bromine, and chlorine. Those are our 7 diatomic molecules. So whenever you see these 7 elements in a word equation, what do you got to do? You got to put a little subscript 2 next to them. Only if they're by themselves, okay? Only if they are by themselves. If they are in a compound, this does not apply. But if they are by themselves, then you need to put a little subscript 2 because they will always exist as diatomic molecules. Okay. So maybe make a little note of that. Only if they are by themselves are they diatomic. If they are with something else, if they are with any other elements in a compound, then we don't do this. You don't put a little 2 there. Only if they're by themselves. Okay, so that's going to be important to remember when we do these this next part, which is balancing word equations. Okay, so practice problem number 22. You do have this one in your book. Okay. It says to write the chemical equation and then balance it from the following word equation. So this one, we have aluminum and oxygen react to form aluminum oxide. Okay, let's go through it because it's been a while since we've done these type of problems. But whenever you see the word written out, so aluminum, what should you do? What's aluminum symbol? Al. Is aluminum with anybody else right here? No. So let's just write Al down. That's what it's going to be. It's just Al, aluminum. Okay. Now, when you see the word and, what should you think?
Line, plus.
Yeah, that's a plus sign. So aluminum and, so let's write a plus sign right there. Oxygen.
Yes.
What's its symbol? What's its symbol?
Oh.
O. Okay. But what's special about oxygen? It's diatomic. It's one of those 7 diatomics. So what do I need to do? Put a 2 as a little subscript right here. Well, you might be thinking to yourself, well, aluminum was by itself.
Yeah.
Do we need to put a little 2 here? No, it's not a diatomic element. Okay. All right, so that gets us through oxygen. Okay, now what do you write when it says react to form?
Arrow.
A reaction happened there, right? So that's where the arrow goes. Okay. And aluminum oxide. Aluminum oxide is a compound. We just got done naming them and putting the formula to them. What do I write above aluminum, guys? The charge. What is the charge of aluminum? Plus 3. Oxide is for oxygen. What's the charge of oxygen? Minus 2. Now what do I do? Crisscross it. Aluminum oxide is going to be Al. What number goes by the Al? A 2. And oxide is O. What number goes by the O? 3. Okay. All right, so there's our equation. Is it balanced as it's written right now? No. So let's balance it now. We find the arrow, draw the line. We've got aluminum, and we've got oxygen. Okay. How many aluminums on the left? 1. How many oxygens? 2. How many aluminums on the right? 2. How many oxygens? 3. Okay, how do I balance the aluminums?
2.
Yeah, put a 2 right here. That gets me to 2 aluminums. Now let's go down to oxygen. Okay, now this is like one we just did. 2 and 3. What's the lowest number that both 2 and 3 is going to go into? 6. So I need to get to 6 on the left side. How would I do that? Yeah, I need 3 oxygen molecules here. So that gets me to 6. How would I get to 6 oxygens on the right side? Yeah, I need to put a 2 right here. That gets me to 6 oxygens. But that switches my aluminum to what?
4.
To 4. Okay. So I got to go back and fix the aluminum on the left. How do I do that? Yeah, this can't be a 2. This has got to be a 4 as a coefficient there. And so we get 4. Okay, can I reduce a... Sorry, that looks so not bad right there. But okay, so we got 4. Can I reduce a 4, 3, 2? No. It's as reduced or as low as it can go. So there's my answer. Okay, word equations are using everything that we know about naming compounds and balancing chemical reactions. These are good problems. We've got a few more practice problems to go through, and then we'll be done. Okay, so practice problem number 23. This is a long one here. So it says aluminum bromide and chlorine gas react to form aluminum chloride and bromine gas. Okay, let's just take the first part of this. Aluminum bromide. Is that a compound?
Yeah.
Yes. What do I write above aluminum, guys?
Charge.
It's charge. What is it?
Plus 3.
+3. What's bromine's charge?
I don't know.
-1. Thank you. We do the crisscross. Now let's write it down. Al is aluminum. What number goes by it? Just a 1. I don't need to write it. Bromine is Br. What number goes there? 3.
Plus.
Okay. What do I write if you see the word and?
Plus sign.
A plus sign. Good job. Now we got chlorine gas. Chlorine gas is just pure chlorine. So what do I write, Tanner?
O2.
Yeah, what's chlorine symbol though?
CO2.
Cl. Yeah, and it's diatomic, so remember to put a 2 right there. Okay, react to form. There's that part again. What do we write when it says react to form?
An arrow.
An arrow. Okay, so put your arrow in. Now we got aluminum chloride. What do I write above aluminum?
It's
Plus 3. What's chlorine's charge?
minus 1.
-1. We crisscross it. Aluminum is Al. What number goes there? Just a 1. Chlorine is Cl. What number goes there? 3. Yeah. And there's the word and again. What do I write? Plus. And bromine gas. Bromine just by itself is what? Is it diatomic, bromine?
Yes.
Yes, it is. Okay, so I need to put a little subscript 2. If you forget that, it's going to throw off how you balance it. So you've got to get the diatomics down. Okay, now let's balance it because it's not balanced yet. So we've got aluminums, we've got bromines, and we've got chlorines.
Yeah.
Okay, how many aluminums on the left? Help me out. Let's go fast. 1. How many bromines?
3.
3. And chlorines? 2. Aluminums on the right. Bromines? 2. And chlorines? 3. Okay, aluminum is good. Let's go to bromine. Again, we have a 2 and a 3, and they're not split, so we've got to find the lowest number that both 2 and 3 goes into. 6. How do I get to 6 on the left side? I need a 2 right there. That gives me to 6 bromines. But how many aluminums now? 2. Thank you. Stay with me, guys. I know this is a long problem. Let's try and get through it. Let's go to the right side then. I need to get to 6 bromines. How do I do that? I need a 3 as a coefficient over here. That gets me to 6 bromines. Okay, now my aluminums are off again. But let's go down to chlorine just because I see a 2 and a 3 again. What should you do when you see a 2 and a 3? Got to go to 6. How do I get to 6 chlorines on the left? A 3 right here, so that gets me to 6. How do I get to 6 chlorines on the right? A 2 right there. That gets me to 6 chlorines. Now let's update what we just changed. How many aluminums did we have now? 2. So did that fix it?
Yes.
So 2, 6, 6. Yeah, everything's balanced. Can I reduce it? 2, 3, 2, 3? Nope. Good job. That's a tough problem right there. That's a long one. So if you can do a problem like that, you're doing really well. Good job. Okay, I got a couple more. Potassium oxide and water react to form potassium hydroxide. Okay, potassium oxide, is this a compound?
Yeah.
Yes, it is. What's the charge of potassium?
Plus 1.
+1. +1. What's the charge of oxide? -2. Let's crisscross it. What's the symbol for potassium?
Okay.
K. And oxygen? Oh, what goes by the K?
2.
A 2. Yeah, that 2 comes down. And then the oxygen is O. Is anything written here? Nope, just a 1, so it's implied. Okay, there's and again. What do I write when it says and? Plus. Water. What's water, guys?
H2O.
H2O. Remember, that's just the common name. We're gonna have to know that one, but everyone knows what water is. Okay, reacts to form. What do I write?
Arrow.
Arrow. Potassium hydroxide. This is a compound. So let's write the charges above it. What's potassium? +1. What's hydroxide?
-1.
Yeah, it's a -1. It's a polyatomic ion. So it's 1 and 1. You crisscross them. You get K. What else? OH. Hydroxide is OH. Do I need parentheses in this case? No, because it's a 1. We don't need to write parentheses. Okay, that's the equation. Is it balanced? No. Let's quickly balance it. Okay, it looks like I have potassiums, oxygens, and hydrogens. How many potassiums on the left? 2. Oxygens. Be careful, it's split. Got 2 of them. Hydrogens? 2. How many potassiums on the right? 1. Oxygen? 1. And hydrogen? Also 1. Okay. This is an easy one to balance. What do I do? Put a 2 right here, and that gives me how many potassiums? 2 oxygens? 2 and hydrogens? 2. Yeah, it's nice when it works out like that, isn't it? Can I reduce a 1, 1, and 2? No. Okay, so there's my answer. Good job. Okay, practice problem number 25. I think this is the last one for word equations, so we'll take a break after this. Okay, we've got iron and water react to form iron 3 oxide and hydrogen gas. So iron, it's just by itself. What do I write? Fe. Do I need, is it diatomic? No, but you should always ask yourself if it's diatomic.
Teachers, excuse the interruption. We ran into some technical difficulties this morning and were unable to practice the assembly. So we need our class presidency and our sub-presidents to report to the auditorium immediately. Again,
Okay.
we apologize for
So we've got the word and. What do I write?
Plus sign.
Plus sign. Water.
report to the auditorium.
H2O. Okay, and then here's that saying again, react to form.
Arrow.
Arrow. Okay, iron 3 oxide, that's a compound. Iron is a transition metal, so we've got this parentheses and Roman numeral going on. What do I write for the charge of iron?
Plus 3.
Plus 3. How do we know that? This Roman numeral is telling us that. It's plus 3. Oxygen is what? Minus 2 charge. Let's crisscross it. Iron is Fe. What number goes by it?
2.
2. Oxygen is O. What number goes by it?
3.
3. That's iron 3 oxide. Okay, and the word and again. So what do I write?
Plus sign.
Plus sign. And hydrogen gas. Hydrogen gas is just pure hydrogen. But is it diatomic? It is. So hydrogen is diatomic. So what do I need to write by the H?
2.
Little subscript 2. Whenever something's by itself, you should ask yourself, is it diatomic? And you'll make a lot less errors that way. Okay, is it balanced?
No.
No. So let's quickly balance it and be done with this problem. Okay, so we got iron, hydrogen, and oxygen. Iron, hydrogen, and oxygen. Okay, how many irons on the left?
1.
1. How many hydrogens?
2.
2. Oxygens?
1.
1. Irons on the right?
2.
2. Hydrogens?
2.
2. And oxygens?
3.
3. Okay, let's balance the irons. How do I do that?
2.
Yeah, put a 2 right here. That gets me to 2. Now my hydrogens are already balanced. Let's go to oxygen. How do I balance it? How many waters do I need?
3.
3. That gets me to 3 oxygens. But it switches my hydrogens to what?
6.
To 6. How do I fix it on the right? I need 3 hydrogen molecules as well. So that gets me to 6. Are we balanced then?
Yes.
Okay, can I reduce a 2, 3, 1, and 3? No. So that is my final answer. Good job. So hopefully that helps you see how to go about solving those word equations. We're going to pause here with the video because you know enough to do a worksheet. Okay? The worksheet in the workbook is titled Balancing Word Equations. So I'd like you to go and complete that worksheet in the workbook now.